Okay, so quite often what you'll be asked to do is to interpret genetic information from a family tree. So you'll be asked to determine what the parents or the children's genotype might be based on that information. So before we have a look at an example like that, there's a couple of things that you need to learn and to be able to do off by heart. So the first one is to be able to describe what Huntington's disease is. So Huntington's disease is caused by a dominant allele. So if somebody had heterozygous alleles or homozygous dominant alleles, then what that would mean is that person would show that characteristic. And the characteristics of Huntington's are late onset, so it doesn't tend to show in the person until they're in about the 30s, very late 30s to 40s. These are some of the symptoms, so tremors, clumsiness, memory loss, and then mood changes. So that's what Huntington's disease is. Cystic fibrosis is recessive, so somebody would need to have both the recessive alleles to be able to show that disorder. So the symptoms are thick mucus, difficulty breathing, lots of chest infections due to that mucus, and digestive problems again due to the mucus. So that's the difference between Huntington's and cystic fibrosis. So be aware of these if you are ever given a family tree. So this is a family tree. Now when you look at this, you'll always be given a key to be able to work that out. So here are the parents, so the mum and the dad, and if you look at the key at the side, the mum's got Huntington's and the dad's got Huntington's. So straight away, what you should be thinking is, right, have they got, which type of alleles have they got? Have they got these ones or these ones? Okay, so the genotype of their parents, now we can work that out, and you can work out what the parents have obviously got by looking at the children. So these are their 4 children, C, D, E and F. So these are their 4 children. Now, if you were to work out what the combination of alleles that these parents have, you would do these Punnett squares. Now, we put those together. Now, it's obvious that these 2 parents must not have homozygous dominant alleles, because if they did, all of the children would all have these alleles, and therefore they'd all have Huntington's disease. So it's obviously not that one. And the same with this one. If this was either the mum or the dad, then all these children would all show cystic fibrosis, Huntington's disease. So it's obvious that this one couldn't be the case either, because all these children would have it. So therefore the parents must be heterozygous. So typical question that you'd get with something like this is, what genotype do the parents have? But don't be afraid to explain why as well. So you must be able to explain why. So the parents, their genotype must be heterozygous. And that's because if the parents were homozygous dominant, if either of the parents were homozygous dominant or both parents were homozygous dominant, all the children would have it. And in fact, child F has not got it.